It's Yaroslav Alexandrov, and together with Larry Sofin and my other partners, we're going to take the next 30 minutes or so to tell about the research we performed in the area of mobile security on Android devices. Mobile apps are a very popular and widely spread service now. The number of mobile app users is growing leaps and bounds, and by now it has already exceeded the number of users of personal computers. Well, which essentially means that an increasing share of personal data, confidential data, is entrusted to mobile devices, and obviously gets processed and often lost and compromised on mobile devices. We're talking about private data, CVCs, CVVs, other bank details, account numbers, you name it. Also, authentication data, logins and passwords, all sorts of things you would like to keep to yourselves. Exploiting vulnerabilities in mobile applications like this can be hugely detrimental both to service users and service owners. Well, this essentially means that research into security of mobile apps is a very important function in terms of contributing to increased security profile of mobile apps. Android almost rules the market for smartphones. We're talking about 40% of the global market, but 70% of the Russian market. Not surprisingly so, because Android devices are often pretty cheap, and the barrier to entry for Android developers is also very low. Lots of developers, lots of devices supported, lots of applications available. According to our experience, even the leading banks today often entrust development of mobile applications to third-party providers. I should be clear that a software developer is rarely an expert in information security, and very rarely will banks demand that particular requirements, as far as iOS is concerned, are observed. And the Android platform itself is full of holes. He was more polite about it, saying that it provides more opportunities both to developers and to the not so well-intentioned guys. So I can tell you that SmartDAC, which is our company, for the last several years have been analyzing mobile applications for a number of platforms, including Android. So on the slide, you see the statistics available on 50 different applications we analyzed over the last 12 months. So all these applications they should have very high security profiles. We're talking about mobile banking services as well as mail services and e-commerce applications. Our analysis has shown that almost half of these applications have critical vulnerabilities. When we say critical, we mean they're easy to exploit, and the impact can be tremendous. We're talking about compromised private data, personal data, financial losses, both for users and service owners. Let me explain the analytical methodology we used. It was analyzed not just the source code of applications, but also the applications that come as part of the binary APKs from Google Play or whatever. When we analyze a binary, what we usually do is to unpack, to decompile APK and convert it into its source code in Java. Then we run on it the well-known automatic static analysis tools, and then the experts are invited to check for false positives. After that, we do manual static analysis. Well, essentially, we read the code. And we analyze a number of other tools. Well, we understand what the functions of an application are and what the vulnerabilities of the platforms are. We know where to focus. Then we analyze the file systems and we do manual dynamic analysis. What this means that we essentially analyze the application as part of a bigger environment. We'll be interested in its interaction with the file system, interaction with the other devices it can connect to. And again, we check all these interfaces for data leakage opportunities. I've mentioned file systems already. The idea is that we analyze different data warehousing, you can call them, could be file systems or logs or what have you, again for the same purpose of finding potential data leakage opportunities. And we also analyze the authentication system for its resilience to penetration. Now, we did a lot of this manual analysis. We have significant experience in this respect. We also had some semi-automated tools. Our findings are as follows. The mobile applications that are expected to be secure, in fact, are not. Many of them have critical vulnerabilities, and the quality of the code on average is pretty low. We realized it would be a good idea for us to collect all those insights and develop a single tool that would have the power of all these insights on board. This is exactly the tool I'm talking about, called Incode. And essentially, it can automate most of the process I previously described. The way it works is shown here. Now we can download a particular application following a link on Google Play. Well, we know that all applications are stored in Google Play as APK files, which is essentially an executable code for a Java machine. It will also contain a number of other important files, including the manifesto, which shows all the permissions available for this file and for this application. So we unpack the APK file, and we get the executable bytecode for the Java virtual machine. It is on the bytecode that we perform our static analysis. We know from experience that it's much more convenient to see the results of this analysis in the source code, not the bytecode, which means that we compile the bytecode back. We have developed a decompiler as part of this analytical device. So it will regenerate the source code while at the same time adding numbers of lines. And that way, your expert will be able to read the source code and will be able to instantly refer between the two files. We also analyze the Android manifesto and the Java bytecodes, but I mentioned that already. Now let me explain what kind of algorithms are run on the bytecode. In fact, we're talking about the full range of static analysis algos. It could be template search, we start out by identifying the parameterized patterns, if you like, that will be symptomatic of individual vulnerabilities. And after that, we also analyze the command flows and data flows. And for that, or to that end, we can use the well-known tools. that we know from the world of compiler technologies. This could be a data flow analysis and synonym analysis, procedural, interprocedural analysis, and so on and so forth. In fact, we're talking about the full range of algos here. What's more peculiar to information security is that we are also using a group of taint and taint-similar algorithms where a particular label, a particular tag can be propagated through the code. For example, this data comes from an untrusted source, so we will be tracking this data until it exits the system. Other labels can actually be fixed as well, such as confidentiality labels. Interval analysis is also used. The idea is that at every point in the program, you'll try to identify, to ascertain the range of possible values for every integer variable. The same goes for arithmetic operations and conditional operations. We also use string analysis for string variables, obviously. And this could be used in order to track pre- and post-fixes, concatenation, and other operations. Based on the research I've mentioned before, we identified several vulnerability classes for mobile applications that we consider to be quite prevalent and that are at the same time quite critical and easy to exploit. You certainly know the official AWASP classification, and it's often referred to as Mobile Top 10. Therefore, going forward in my presentation, I'm going to use that classification. First class of vulnerabilities are those that arise during data transfer. Let's look at how they actually arise. For example, when an app is talking to a web server, it can be doing that via a non-protected channel, such as HTTP. It doesn't happen very often, but it does happen, particularly when it connects not to the main web server, but rather to auxiliary web services. Card information, for example. And again, this could be hugely dangerous. This is, by the way, a way to mount a phishing attack. Well, secondly, there are vulnerabilities linked to well-documented vulnerabilities in libs. Also, there are some other well-known vulnerabilities, such as not checking for certificate chains when SSL connections are set up. This is, in fact, something that happens very often. Well, it somewhat weakens MITM sort of attacks, but it doesn't invalidate them completely. Such vulnerabilities can be found using template search, well, confidential data leak can be looked for with an adaptation of the taint analysis. Could be functions or heuristics. We got several heuristics tools in order to ascertain whether a particular set of data is indeed confidential or not. So in the AWASP Top 10, we would be looking at, number 3 and 4. Now, the next group of vulnerabilities is linked to data storage. So During path traversal attacks and other cases, attackers can get access to home dir, external memory, cache, exchange buffer, or logs. Therefore, storing sensitive data in all those areas is very stupid. It's very easy, by the way, to identify all those vulnerabilities using template search, taint analysis, and other tools. Next vulnerability class, which is quite typical of Android because the previous two would also apply to iOS, are linked to inter-process interaction. This is something that is used very often, and we believe that is used very insecurely in most cases. So this inter-process interaction can be linked to services, activity, intent, content providers, and broadcast receivers. What kind of vulnerabilities could they include? Well, for example, if your application does not really close these components from other applications properly, some other application can easily claim access to them. And for example, your application could be sending PIN codes or passwords or other confidential data using a broadcast message. An attacker's application can easily intercept this data. Well, if instead you're receiving broadcasts, this essentially means that malware can send you a particular message, your application will process it, and will be compromised by doing that. Well, this is your classical DOS scenario, where if you don't check for nulls, you can easily flood the system. And again, this is how a phishing attack can also be mounted. You usually find these vulnerabilities by way of template search and different verifications. Please note that the algos we use for analysis should usually meet two criteria. First, they should be comprehensive. We want the tools to give us some reading, if you like, on as wide an array of vulnerabilities as possible. And on the other hand, we want our algos to be in line with our own criteria. And we want to minimize false positives. This is a well-known problem of static analysis. Well, quite often standardized heuristics are used, and they can take into account the peculiarities of a particular platform. It's also very important in mobile applications to use reliable crypto. Well, quite often poor crypto is used or poor hashing is used even for confidential data. For example, many apps still use ECB crypto. Again, it's easy to ascertain all that by using template search or taint analysis. Mobile applications, just like any other user services, have a wide range of vulnerabilities related to poor checks of input data. This is the stuff that usually people search on the web, for example. So we're talking about injections, code injections, SQL injections, path traversals. This would be the classical taint analysis case. So we need to set up a base of our sources and what have you. I'm sorry, that would pay due respect to peculiarities of individual platforms. Finally, we're going to show you a short demo that will illustrate our methodology on the basis of a specific application. You are going to see all the steps of our analysis: unpacking, disassembly, decompilation, analysis. And you will see how we are using our particular utility. So most of the stuff will be automated. For demonstration purposes, we've selected an application from one of the larger banks. And we are quite comfortable showing this stuff to you because the developers have removed the vulnerability, but we've tried to camouflage the bank so they don't feel bad about it. So you're going to see how the analyzer processes the file, looks for vulnerabilities, and then we're going to use a fiddler in order to try exploiting it in real time. And we'll also need a device emulator for that. Sounds like they have one. So I'm doing exactly what I said, right? We are uploading an APK to the analyzer. Most of the stuff is automated. We go straight to the end of the analysis itself because waiting for it would be a bit too boring. Now these are the results. So you see there are several critical vulnerabilities. And the results show that many of these critical vulnerabilities mostly fall into the category of weak SSL, poor certificate chain checks, and no checks for domain certificates. So we decompiled the codes together with the line data. So it's very easy for us to see which classes they belong to. And you will see that verify, for example, will only return true. Obviously, this application is vulnerable to the man-in-the-middle attack, which means that we are going to use the fiddler and the mobile emulator to exploit it. People are laughing because the bank obviously has not been properly obfuscated. So we've entered the login and the password pair, and the fiddler intercepts, hijacks the connection. And now we see in plain text the login and the password. Please note that we did not change anything. We did not install the certificates here, which actually could change the situation. So it's important to remember that such vulnerabilities exist. Maybe they're not so prevalent, but this particular certificate vulnerability, for example, is quite prevalent. Please remember that such applications are very vulnerable to man-in-the-middle attacks. All you need to do is just make sure that the user installs a particular certificate. But that could be also pretty dangerous. Guys, we just told you about our experience in researching mobile applications for Android, with reviewing, ensuring, or checking their information security standards. We've also explained the way our analytical methodology works, and you've had a meager chance to see how the tool works. We're not trying to say you can fully automate everything. You will still need to do manual work, which means that your information security experts are not going to become jobless. Some vulnerabilities, though, can be verified in dynamic mode, others will need to be verified statically. However, this tool automates what can be automated and also enables you to analyze the application in binary form. Thank you very much. That puts the lid on my presentation, and these are our contact details if you have any ideas. Oh, you see, I see you have a question. Please use mics, gentlemen. Hi, my name is Yuri. I'm gonna comment a couple of questions. What do you think about excessive logging of messages? I think you had a slide that talked about info storage on SD cards. I would also add the idea of logs there, because this is what happens very often. In mobile applications, excessive logs are kept, at least debugging logs, or in fact everything can be logged. Actually, I think we had this line somewhere in the slides. You're absolutely right. This is true for the file storage, cache, memory. Not memory, something else, I'm sorry. So, logs often contain the most sensitive information, including passwords. This is a true vulnerability, you're right. Did I get it correctly that Android binary analysis enables you to bypass obfuscation? Because classical analytical techniques usually work on source code. Well, we know that malware applications often use premium obfuscators just to avoid discovery. That's right, but there are different levels of obfuscation. These automated tools are pretty good at doing away with simple obfuscation. Now, if you're using some sophisticated obfuscators, that would certainly create problems in the decompilation process. So this would be the area for development for us, to ensure support for proper deobfuscation. Okay, you've mentioned false positives and false negatives. What was a bigger concern for you, to reduce the number of false positive or false negatives? And what do you think is the current ratio between the two categories? And if you could compare yourselves to competing solutions, because there are some, right? We have App Scanner, Fortify, and Application Inspector. Well, I mentioned that we always have two objectives. We want to reduce the number of false negatives, to use your language. In fact, there is no inherent conflict between between avoiding false negatives and false positives until a certain threshold is reached. We're using different intellectual techniques in order to verify the vulnerabilities found. We understand we need to find the golden mean between them. It is more important for us to reduce the number of false negatives. That's why we're so serious about assigning criticality levels to vulnerabilities. Obviously, we have more false positives than false negatives. Can you compare yourselves to any vendor? You know what? We're not a vendor. At least not yet, so we haven't really done this comparison. We believe that such automation enables you to analyze APK files from Google Play, and I don't think any commercial product has this function. To be more precise, we know that IBM has a module that supports it. We tried testing it, and I can assure you that results were very underwhelming. Very few vulnerabilities were actually found by the tool. So I think we actually have a serious advantage over them. As regards the algo base, I think we're using the same static tools as Fortify and others. We're developing our database, so we think we can be stronger than they are, but this has never been our objective so far. So far, our only objective was to cover Android properly, to ensure proper reach. And I think we've been successful in doing that. Okay, it sounded like you had some vendor ambitions. Is that true, or are you only doing it as an internal pet project? Please stay tuned. It will happen sometime in the future. Okay, thank you. Arkady Prekunin from Open Security at Kryte Bezopasnost. I understand that Encode is your in-house development. Well, we did it in partnership. Okay. You have a logo that reminds me of Solo Security, which is not a coincidence. They are our partner. Are you going to sell it, or what? I'm not going to answer your question, sir, with due respect. In several months' time, there will be a public announcement. But you can already provide your services based on that solution. That's right. Is there a beta version or something, a test version available publicly? No. Publicly, certainly not. Indeed, we've been providing our services in this particular market segment for quite some time, and therefore it's not publicly available. Let me ask you a more in-depth question then. Have you considered any Android libraries, any filters such as XSS filters that would enable you to filter user data and put them into rules? Because there are there are libraries like that that enable you to filter out special characters. You're essentially asking us about our database for sanitizers and taint analysis tools. Well, we are working on that, absolutely. What's most important for taint analysis is to collect a good stock, if you like, of tools, sanitizers among others. Most of them are libs. We can't really guarantee that this is the most comprehensive database you can find, but we hope it's close to that. Do you analyze hybrid applications that would have some native, components? No, we are not doing that at the moment.